OBC. Yeah, there you go. Very good. Yeah, especially like this is quite niche. Did you go to one recently? At least you don't have to get to passport to someone pretty different. A lot of our speakers like, are you in the remix thing? I just spent a lot of money on that. I was so I was like, I actually reached out to them. All right. I was already talking to them, and they were like, by the way, we're about to schedule like some secret. All right. You're now really seeing yeah, they're on the design. Yeah, they do, right? And in Australia, I know. Exactly. Yeah, he did. Yeah. My manager. I'm sure exactly what he did. All I know, practically, my coach said Dion was very much like a fan of remix. He played a big role. It's really a big strategy. I'm not sure why that looks like a strategy. They just they don't really literally the CEO he's still a hands-on. Yeah, and he loves remix. That's good. I appreciate it. So that was partly about sort of I started talking years ago that our ecosystem. I know they want remix so yeah, because I mean, I think there was a sense of like they wanted to make it easier to mention. And they had their own framework and they still do. So the difference now is like clients didn't used to be its own framework. Now, it's actually built on top of frameworks. Right. So it's almost like actual remix too. Yeah. So that you might. I don't know how much I should say. Yeah. It's still new to me. What is remix versus we had literally this something I've been involved in a remix, but and I was like, we did on this issue, and I was like surprised how the integration was just completely so it's like, it's a little confusing. Where this the line between remix and so Michael, early I like seeing all the witness together. You already okay. And have you got your slide set up? Yeah, I have. Oh, okay. They're on there. Do you want to? Man, that's easy. Yeah.
I think 12 hours that I felt like I tried yesterday was half an hour. That's the only thing that I yeah. So that was like the only one thing that was recommended that how should you the weather. Yeah. Did you have any? No, but yeah, I did see them. I did follow the freeze. And today, it's out to because I tried yesterday. I jumped my bag to the hotel and I climbed the toll bus and I was out till like 10 p.m. Damn, I did. Yeah, so 12 and a half hours I crashed. It was watching. and there was like a lot of turbulence on my flight. We left an accident just to remind us every 15 minutes. And you know what? That's the story. But again, don't keep reiterating that. You're making it worse. Yes. So, the 6 months are great. Like, why I get a lot of sleep. So, yesterday I half contemplating not to go for that trip because I'm like, I might not be able to enjoy it as quickly after the shape when I reach out. I can't walk, I can't I just cry. But those books are like 2 p.m. So hours. Yeah. Like, the tap is about yeah, so I have to yeah, I mean, I actually not expect to fall sick with right yesterday. I'm grateful that I had this opportunity outside the conference.
Golden fleece. I don't want it to miss it. Yeah, we don't want to put it around here. Yeah. Yeah, that's all.
Okay, folks, why don't you grab a seat and we'll grab a bit of your food, grab a drink, and we're going to kick off in just 20 seconds. Anybody who's watching on the stream, take a break, sit back, relax, and we'll get started in just a second. All right, people are going to stand by over there by the food. All right, that's all right. I'm not shaming anyone. Good evening and welcome. Before I begin, I'd like to acknowledge the Kulin people here, the traditional custodians of the land on which we meet, and acknowledge their elders past and present. Welcome. My name is John Alsop. I'm the founder of a thing called Web Directions, which is one of the reasons we're here tonight. We're here for a bunch of reasons. One of them is Kogan, who very generously hosts React Melbourne every month or so. So thank you to Anita and to Kogan for hosting us. Anita's over there. Kogan have a bunch of engineering jobs open right now. So if right now you're between, having a career change or you're between jobs, make sure you go and have a chat to Anita or have a look on their websites. There's a bunch of jobs open there. And thank you very much to you, Kogan, for hosting us tonight. We've got a couple of speakers tonight. I'll introduce them when we get there, but I also just want to talk about, for some reason my slides, there we are. So what we've done for years with our Code conference, which has been running in Melbourne since 2012, a little bit of a hiatus where we went online due to things we won't mention anymore. So we're back after 4 years, which is great. And we've had this long tradition of bringing along some of our international speakers for a meetup the night before the conference, right? So Code is all about front-end engineering. We've had a bunch of amazing speakers over the years. It takes place tomorrow and Friday. If you've got some training budget left in 2020, whatever year this is, 2023, come speak to me, we can sort you out. But in particular, we've got 4 really great meetups who have sort of come together, bringing their community together for tonight's event. So we have obviously React Melbourne, thanks very much to them. We have Melbourne CSS. So Chris up the front. So if you're a CSS person, awesome. If you're a React person, come learn about CSS. It's still pretty awesome. We also have Melb.js. So we got Mark Dalglish and we got Chris Taranto, Chris Taranto. Is it? Who's still involved? Michael Taranto. Sorry. All right. It's been a long few years. All right, Michael Taranto along here. So there's a great meetup happens every few weeks down here in Melbourne as well. You should get along to it. So we're bringing all those communities together, and we have got 2 fantastic speakers who've come all the way, in one case from Mumbai and in one case from Copenhagen, to speak to us tonight. So we're going to kick off with, if I can find the right slide, I don't know what's happening here. I built my own slide system, this is what happens. All right, it's not going to work. All right, first up, not you. First up, we have Kenneth Christensen. So Kenneth is at Intel, where he's a very senior engineer who looks after a lot to do with the web there. He has been on the W3C's technical architecture group, which is kind of like a very senior group of the W3C that looks after the technical direction of the web. If you've heard of a thing called Project Fugu, he's been instrumental in that. If you haven't, we're going to learn a bit more about it. So Kenneth tonight's going to come along and talk about some of the future direction of the web, like some super amazing stuff that not only is coming to your browser, it's already in your browser you may not know about. So to kick off tonight, would you please welcome Kenneth Christensen.
Let me just find my slides, if I can figure out how this works. So, is this working? Perfect. Yeah, hi. Oh, I don't have a microphone here, so I guess I need to stand here. So yeah, my name is Kenneth Christensen. I am a principal engineer at Intel, working on web browsers. So we work with Edge and Chrome. So actually doing the implementations, as well as working on like newer standards, trying to like find the direction of the web and what really matters for us. I'm also a co-inventor of Western Web Apps, and as John said, I've worked on the technical architecture group in W3C for 4 years. As well as other things. So the first thing you might be wondering, like Intel, well, that's a semiconductor. Why are you doing things on the web? Well, the thing is that today the world runs on software. And you can have the best hardware in the world. You might even have like specialized hardware. But if you as a developer can't use it, it's kind of useless. You're just paying for that hardware. So we need to work on that as well. And Intel, we're really a true, strong supporter of open source and standards. We have this new saying that we really value openness, choice, and trust. And this talk I'm doing today is basically like a shorter version of the talk I'm doing tomorrow at Web Directions. So if you're coming tomorrow, you'll see some repetition. So why is the web doing well? Well, the web and progressive web apps today, they really dominate the PC users' time. Actually, on our Evo platform, that's one of our prime platforms, more than 75% of time is spent on web properties, like websites. On regular, it's more like 60%, 65%. And that is just with the browser. If you then include like something like Electron apps or other apps, it's even more than that. So really, like web is very important. If you look here, like you'll see like the top apps on Windows is Chrome. Second one is Edge, that's also a browser. Then you have Firefox, it's also a web browser. Then you have Outlook, and Outlook is actually a progressive web app today, and it's becoming Windows 11. Then you have other browsers like Brave, Vivaldi, and then you have like Excel and Word, which is also becoming progressive web apps. It's pretty much the web. So the web is doing really well because it's on the right path, because we try to make sure that it is on the right path. Like it's becoming this unrivaled application development platform, especially for desktop. So we have solid building blocks for creating web apps. We have installability, you have the web app manifest service worker. You create web app experiences that you can install that act like native apps. We have improved the core of the web, better CSS, we have CSS grid, Flexbox, we even have container queries now. And we have a lot of group working in something called OpenUI, where they're trying to come up with new HTML elements that solve actual user needs, like a new stylable select element. We're just like shipping like popover, which is even in the next version of Safari. So it's really amazing stuff is happening. We also have working on newer things like navigation API, like routers. You probably use that if you're front-end developers. There's a lot of quirks with session history. So at least like Chrome and Edge ship the new navigation API that solves a lot of this. That can hook into the new view transition API that allows you to do amazing animations, just like native apps. Like you click on a video, like preview, and it will just like zoom out and become like a whole screen thing. You just click back, it will go back. It just looks very smooth and nicely. And then we also have a relentless focus on performance. So we worked on WebAssembly, optimizing WebAssembly, coming up with new standards such as multi-threaded support, working on SIMD, we'll talk about it later, it's called single structure mobile data. There are like libraries like MediaPipe for Google that can do like background blurring in meetings. Let's optimize that. Let's add support for native background blurring instead. Let's add support for machine learning, because that's what everyone's talking about today. So we're really trying to make sure that we have the APIs that developers need, as well as a roadmap that shows that you can really invest on the web, because we're also going to be there for the next big change in our industry. Like today, that will be machine learning or whatever comes next. So we really also innovate on capabilities, especially as part of something called the Project Fugu, where, for instance, we're working on file system access, Bluetooth support, etc. We really want the developers to be able to bet on the web. So create these experiences with ease. It should be easy to develop great experiences. We don't want people that have to massage the platform always. Like sometimes it's great that you get these libraries, frameworks that do everything for you, but sometimes they're working around the web. They introduce a lot of magic, so developers don't understand what's going on below. So if they want slightly different behavior, it's very difficult. So we really want to provide like approachable, good APIs for creating these app-like experiences. We want to stay interoperable, so if you're using one framework or one library, you can use it together with all the other libraries. Work on these new APIs as navigation API, view transition, etc. But we also want to have APIs that are required for creating diverse experiences. We don't want the web just to be for going to doing like an e-commerce. If you want to be Lego, you want to do like a website that can connect to your Lego toy and maybe control it. Well, maybe we need the Bluetooth API then. Like we want to have APIs for all these kinds of experiences. This is just for a subset of experiences. And I'll show you some examples later. But we also want to be there for the next industry revolution. So here are some examples. As I said, we worked on this project Fugu, that's the capabilities project. We're working together with Apple and Microsoft and Google. not Apple, Microsoft, Google, and Samsung. And for example, here you have like Visual Studio Code that can actually run in the browser. If you just go to vscode.dev, it will launch, and you can open up files from your local file system and just get started coding. And that works because we have the file system access API now. We have like Photoshop, and Photoshop, like, it's kind of amazing. People for like, the one app that's never going to run on the web is going to be Photoshop, and here we are. There's Photoshop, and like, why is it running on the web? Well, first of all, they're using WebAssembly that takes the C++ code base, the existing code base. They couldn't like start rewriting from scratch; it would take forever. They could bring that to the web. Super awesome. It wasn't performant enough, so they couldn't really use it. But then we added like support for threading, so they could use different threads. Then there's this thing called single structure multi data, where you can do like, instead of like multiplying like a scalar, you can multiply a vector with a vector, so it's much faster. There's actually one case where it's 160 times faster. This is like amazing. On average, like I think like 3 to 4 times speed up. But this made Photoshop doable on the web. Here's another example. This is like Roomba, like the iRobot. They have this product called like Root. You can buy for education, and you can program it using your web browser. It works everywhere, and that just uses like web Bluetooth. What is interesting is that while adding all these APIs, we really focus on safety and privacy. A lot of people have this idea that, oh, on native apps, like everything is safe because install it. That's actually not the case. The case is that people have this fake feeling of safety because it's review, it's great. There's so much you can review, right? You get a binary file, you're looking at it. Maybe we use the machine learning to find out what's going on. But like the thing is that on the web, you visit a lot of websites every day, every month. So it really needs to be safe. So we're always trying to innovate to make sure that how do we make it clear to users what's going on. Like, for instance, like example with Bluetooth. Like Bluetooth, there might be a lot of different Bluetooth devices around you. That should not be exposed to any website. It's only when you decide, okay, that's the device I want to connect to, you make that connection. So always think about privacy. But also you can add all these like dialogues asking for permission. But if people have no idea what is a wake lock, like they're gonna say yes or no. And there's also gonna be this fatigue. I'm seeing so many dialogues. I'm always gonna answer yes. I'm always gonna answer no. So we're always trying to keep that in mind and design these APIs in a way that it's safe and privacy preserving. And like I said, today everyone is caring about AI. So AI is everywhere, and one of our partners is Zoom. So we work with Zoom on actually leveraging AI, not as a direct API, but at a higher level, like make it possible to, for instance, do background blurring using AI just local to the device. Something else we worked on is like web codec. So web codec allows you to talk to native codecs on your system. So a lot of hardware today actually can encode and decode different video formats. So why should you be able to use that? But you don't want just to like, oh, play back this video. You might want to say, oh, well, I want to encode this video chat in this resolution using this frame rate. So you want to be able to configure it. So we have an API for that today. One of the other things we've been working on is web GPU. So we're bringing basically modern graphics and compute to the web. So this has a lot of deep involvement from Intel. We started around like, I think sometimes in 18. And we're actually working on the implementation, and this is shipping today. You will notice it's a bit small here, but you see like Sundar Pichai from Google actually announcing that at Google I/O, and Google actually saying that like they're thanking Intel for support of this. And this is really cool because AI, like web GPU, is great for graphics, but it's more than graphics. It can also be used for compute. So you could do, for instance, AI using web GPU if you need to. So, for instance, Intel has been working on porting TensorFlow.js to use web GPU. And we are basically like the initial owner of that backend, and that is becoming more and more mature. So here's just some example. This might be a bit small, But here you see that the back end of WebGPU using WebGL in comparison with WebGPU. And you see there's one case where it's actually a bit slower, but in general, like it's faster. So here's one example. I know it's just going to play by itself. What do we need to click? Oh yeah. So here I'm doing like stable diffusion using WebGPU. It's just in the browser. So there you go, 7 seconds, and that was just using WebGPU. So what's interesting about machine learning today is that people have this idea, well, machine learning is like, if you use a GPU, is perfect. That's always the best solution. That's not actually always the case. It really depends on what you're trying to do. In some cases, on small models, CPU might actually be better. First of all, normally the data you have to prepare is on the CPU. It shares the memory. So if it's on the CPU, the memory is already there. As you see here, you don't get the best performance as you scale, and it's using a lot of power. But if you need like low latency and it's just a once in a while thing, it's actually better. If you want like some like sustainable AI running all the time, discrete GPU is often the best solution. It requires less power. It still requires a lot of power, but you need to take all the data and actually move it to the GPU. And then it's running all the time, it's fine. If you have an iGPU, an integrated GPU, now in some cases it can actually share the memory with the CPU, so there's less copying. And they have this new thing called like an accelerator. They have different names. Microsoft call it NPU, and Intel we call it VPU for versatile processing unit. Google call it a tensor processing unit. It has many names. And you see here, like, that is pretty good for performance. You still don't get maybe the performance of a GPU. Anyway, I just want to highlight that there are many different solutions for this. So at Intel, we've been working on, especially together with Microsoft, we've been working on Web Neural Network API. Just for instance, we are launching this year a new process from Intel, codenamed Meteor Lake, and that has a built-in VPU, so built-in accelerator for machine learning. And what is really interesting, this is the first time ever that we've announced a product from Intel that actually has a web API on the slide. This is an official slide from Intel showing Web Neural Network API support. It's also interesting from Microsoft Build, there's a nice quote here, like we work on WebNN, it can do local inferencing in browser, was implemented WebNN standard, working with Intel. It's coming soon at this point. A lot of excitement about bringing machine learning to the web. Here's one of the examples of the speed up we're getting using WebNN. So this is on CPU. The one you see is by using something like, I think this was a MobileNet V2 on a WebAssembly. So that's a 1, that's the performance you get. If you then start using SIMD, the single structure multiple data extension that we added to WebAssembly, you get a 3-time increase. If you use WebNN instead, here based on CPU, it gets a 9.6-time increase. And you see it's almost the same speed as native. So really a big change, and you see this is across the board in all of these examples. So here I have like one example from a co-worker, Belem Jang, out of Shanghai. So he's showing like some of some background blurring and video segmentation using WebNN. So I don't know if sound is working. It's probably not.
Now I will showcase the background blur performance with
it's very slow. It's very low.
It is a
so anyway, he's running
I will compare
this on CPU and I think WebGL and I forgot. Like he will show you
background blur button. You will see the inference time.
Oh yeah, it's with the WebAssembly SIMD and WebNN, and you'll see the difference.
Furthermore, on the right side,
so this is with WebAssembly.
I collect the performance data for every 2 seconds.
Every
Display
2 seconds?
of 11 groups and calculate the median value of them. Let me click the WebNN backend.
And now we'll try with WebNN instead.
The inference time and the frames per second is faster. And the performance.
And I don't know, this is apparently cutting the difference, so I see that on my screen. But you see, you get a speed up of something like 2.3 times.
Faster than WebAssembly.
just using this model, using WebNN
Now,
and using
I will
WebAssembly.
showcase the background replacement performance with DeepLab model. It is a relevant bigger model than
And now we're
self-based
trying deep learning
implementation.
models as
And
a
I will
larger model.
compare the WebAssembly performance with WebNN. Let me go to the full screen and click the background replacement button and change the background at first. It's running on self-based segmentation now. Let me click the
So this is a segmentation model that's running here, and
by using the
you see the
WebAssembly
difference.
backend, you can see the inference time
So
is
the frame per
only
second is pretty low using
130
WebAssembly.
milliseconds, and the frames per second is about 7 in the indicators.
See, 710.
Let me switch to the WebNN backend. The performance is much
And here you
faster.
see we get like a 4 times speed
The
up
inference
just
time
using this new
is less
API.
than 40 milliseconds.
So why we're bringing a machine learning to the web? Well, obviously, it's like I said initially, we really don't want the web to be left behind as the industry is moving to a new area. Also, it enables a lot of new compelling use cases. So it's very, very important for us. If you look at the existing ways to use machine learning on the web, you can use WebAssembly, it's CPU only, or you can use like GPU, it has compute, so we can also do that, it's GPU only. But with WebNN, we can do this with any of these APIs. We currently have in Chrome, as a dev trial, implement this with using CPU. But we're also working on implement this using GPU as well as our accelerators. So this is just like a short version of the talk I'm doing tomorrow. So I just want to highlight that Intel is really working on empowering the web and future experiences. So I hope this was interesting, and I hope you join me tomorrow at Web Directions. So.
Thanks, Kenneth. So we might head on to have Divya now, and then we might do some QA at the end. How's that sound? All right. Okay.
Do you want to have your talk?
Yeah, I have to open the left side to
All right. We'll just set it up. So I'm sure there's a bit of pizza left. Is that another drink? We'll just be a couple of minutes while we set this up.
I hopefully have set it to the right person.
Oh, this one, yeah. This one?
That's cool. Yeah, thank you. I will just bring my
All right.
bag also.
Okay. Well, then we'll, yeah. Go grab your bag.
Then I have a bag.
I think so. Over negotiation of those. Okay, correct. Are you good to go?
Yeah.
All right. Okay. Perfect. Okay, so next we have Divya, who's flown from Mumbai the last couple of days. So Divya is a senior developer relations engineer. Will that do? That close up at SUSE. Apparently, that's how you pronounce it. I always thought it was Suze, like as in Dr. Seuss. So anyway, Dr. SUSE. And she's done a lot of work around WebAssembly for a long time. So it's a great privilege to have her here to tell us a bit about where WebAssembly is at and where it's headed. So please welcome Divya Mohan.
Hopefully I'm audible and visible because the podium always does me wrong. So thank you, John, for that wonderful introduction. And yeah, so like John said, I'm here to talk about WebAssembly, or rather the problems with WebAssembly. And I know that kind of sounds funny because, you would not expect someone to outright come and tell you what's wrong about something, right? When you listen to any presentation or session, they always show you the good parts. And that's something that I also do as part of my day job. So I'm not completely swearing off it. But honestly speaking, I think it's absolutely essential that we talk about the multiple elephants in the room when it comes to WebAssembly. And I'm gonna maybe give like a short brief at the end as to why I'm still very much optimistic about where we're headed. So I know that I gesture a lot, and that's I'm going to stand right here. It's the Indian in me, and I'm really sorry about that, but That's the premise of the presentation, the problems with WebAssembly. And let's get started. So, as John introduced me, I'm a senior tech evangelist at SUSE. And yes, that SUSE does mean something in German. It's an acronym for something, and I'm definitely going to get it wrong, so I'm not going to say that. I'm an advisor to another cloud native company, which is Avesha, and I'm a CNCF ambassador as well. But I was not all of this for a really long time. I was just a systems engineer hacking away at systems for nearly 8+ years of my career. And I considered myself an unpaid therapist to a lot of developers because I worked alongside them for a really, really long time helping them solve their production incidents. And those were often like really, really high-stake incidents. And yeah, so my journey into WebAssembly, to be honest, is a very roller coaster. I wouldn't say roller coaster, but very curvy one, because I ended up, I should be the last person standing here talking to you about WebAssembly. I worked on systems. So it was because I was this free unpaid therapist to a lot of developers that I found my way into WebAssembly and have worked thereafter in this ecosystem. But let's take a step back for a bit, right? Why would I or anybody in this room be interested in WebAssembly? Because the last time that I checked, it's been 8 years since WebAssembly has made its mark, or supposed to have made its mark in the tech industry. The MVP was announced in 2015, and then 2017, the framework was supposed to have been announced in 2015, and the MVP was supposed to have been delivered in 2017. So, honestly speaking, if you think about it, it's been 8 years. And given that 8 years have passed, not a lot of people still know where WebAssembly is at. Leave alone know where WebAssembly is at, a lot of people don't even know what is WebAssembly. And that's strange because to me, I came to know about WebAssembly 2 years back, and that's saying something. Like, know in the sense completely start working on it. And this is sort of the timeline, if you look at it, for WebAssembly. I just spoke about it, right? It was announced in 2015, and we delivered MVP in 2017. But honestly speaking, we haven't caught up yet with like the various other technologies in terms of actually being out there, doing something, getting that major widespread adoption that people speak about. Why is that the case? If you look at Google, it'll give you like 10,000 articles on why people think it's a bad idea. Of course, they're entitled to their opinions, not going to say they're wrong. But is that due to poor advocacy on our part? Is that because it's not that great of a replacement to JavaScript? And I'm not saying that it is a replacement, but people do liken or equate it as a replacement to JavaScript. Is it because, people are too, not ready to accept it as one of the other languages? Or is it because, there's a steep onboarding curve? That is the premise of the presentation. That is what I'm going to discuss. And I'm going to discuss that basis the various questions I get when I have these conversations around WebAssembly. But obviously the very first question is, what is WebAssembly? Because that is like the very first question. Is it assembly programming language? Is it like assembly level language where I have to like type out instructions? Is it that? Or is it like just for the web? So I'm not going to sit and define it here because I'm not the definition authority. So it's a binary instruction format for a stack-based virtual machine. You can use it. It's designed to be a compilation target, and it can be used on both the client as well as the server side. Sorry, for deploying applications. Now, when I just said that, a lot of people must have thought, hey, you know what? We already have technologies doing that. We already have tools doing that. So why are you exactly going about reinventing the wheel? Like, is this like another form of bike shedding or yak shedding that you're not doing by reinventing the whole process of, how we build software? Um, in in the container side or in the server side of things, where I grew up as a technologist, we have containers, right? We went from physical servers up to containers, and now we're trying to deploy stuff on various devices that look nothing like the servers, but are servers. So we are moving to these edge devices. And at the front end, we already have JavaScript doing the work. We are bringing languages to the web via JavaScript. So why are we actually reinventing the wheel? So I'm going to play up to my strengths here, because at least I'm going to start off by playing to my strengths here, by speaking to the server side of things. So the very first job, or the very first couple of jobs that I had, dealt with me being a middleware systems administrator and engineer, where I dealt with the build, design, and deploy, and maintenance. How can we forget that? Build, design, deploy, and maintenance of applications. And when I worked alongside developers, one of the first things that I noticed was there was no consistency in environments when you had an application in development versus when you actually deployed it in product. And as times progressed, and as my previous employers moved from like tightly coupled physical servers to actually having applications run in the cloud and then on Docker and containers in eventuality, we solved some of those problems. But honestly speaking, not all of those problems was still resolved, because that last layer of abstraction is still there, wherein you need to have libraries that are very specific to a particular language. And believe me when I say that the amount of redundant code written across an enterprise is enormous. Like, I don't even want to get into tech debt and bureaucracy when it comes to an enterprise or a MNC. But that amount of redundancy is simply mind-boggling. What if there was a better way to do things? What if there was a better way to build software? And that is sort of where WebAssembly was, fitting into my brain as a use case for the server side of things. And that's how I got interested. But obviously, when it comes to the front end, I'm not going to be standing here and preaching to all of you as to why we should reinvent the wheel. I am not going to do that. I'm not asking you to break the wheel or reinvent it, because I realized that it's kind of like putting my hands inside a lion's mouth. It's kind of dangerous, because I am really not, I'm a self-taught developer at best. But I really am passionate about learning new things. And I think you're way more qualified than I am. And you'll know it as much as I do, that when we try to bring more programming languages to the web, we do have issues. We might not speak about them as much as we, like it or not, but there are issues when you bring programming languages that are higher level to the web. And that is what is, I think, a possible answer, like bringing more languages to the web, building, bettering the way we build software, and improving, the way we build software. Those, I think, qualify as possible answers, but the jury is open here. But even when you talk about all of these, one of the things that kind of comes up every time I have a conversation is like, hey, but you know what about the developer experience associated with WebAssembly? Because I've heard that it's quite shitty. This is a real quote, by the way, from someone I met at a conference. And in my opinion, great developer experience actually has 3 pillars. You have to have like a gentle onboarding curve. That's never there, but in theory, you should have a gentle onboarding curve. You have to have a robust tooling ecosystem, and you obviously need to have awareness and education about the technology. In the context of WebAssembly, when we talk about all three of these, the first one up here is onboarding curve, right? When we talk about onboarding more developers, because we truly want to enable you to actually write once and run anywhere. We started off like that, and I still, have vision. I still hope that we actually hold on to that vision of writing once and running everywhere. And if we actually look at WebAssembly today and see where we are at with respect to that vision and how accessible it is to developers who write in other programming languages, just not JavaScript, I don't think we're there yet. Like this, I know it's very small, but this is the best I could do with my screenshotting capabilities. But if you look at the top 30 languages by RedMonk, and you contrast them with the capabilities that have WebAssembly enabled in them, namely, the WebAssembly version 1 implemented in their official compilers, at least a single browser implementation or in that particular language, and WASI support. WASI is the WebAssembly standard interface, and it's an important framework that is developed as part of the WebAssembly ecosystem, so that your applications, once compiled to WebAssembly, actually can function as applications. Because on its own, WebAssembly is just a sandbox and it can't talk to anything else. So it needed the specification. So if you look at these capabilities, you notice that there's a discrepancy. Like there are several that are, still having that, what do you call it, the small thing, that hourglass thing. And you have certain ones where they are like, they've crossed it out completely. So when you talk about support, onboarding support or onboarding curve for developers, we want to enable developers, but we don't have support for your language in this particular environment. So what you gonna do? Like, how is it really helping you? Do I have to learn another programming language so that I can actually leverage WebAssembly's apparent benefits? So that is one obvious issue, that we don't have support yet for a lot of languages. And there are some like TypeScript who've withdrawn support from AssemblyScript as well. So there's a whole, fragmentation process and bike sharing that's going on in the ecosystem right now. But extrapolating that to the tooling ecosystem, if you do not have support for a particular language, you obviously cannot develop the associated tooling as well. That means an even more poor developer experience. And it further degrades the experience of those who are trying to get started. Like, I hope that some of you actually go and Google what is WebAssembly and try to get started after the presentation. But if you piece what I just said together, you'll probably be like, hey, you know what? It's not probably available in my language, but I should have been tried. And last but not the least, awareness and education, right? When I started out, there was like, I think one Google search page that was about WebAssembly. There was one whole Google search listing that I read through for understanding WebAssembly. One listing was just about the WebAssembly's website itself, and the rest were blogs. There's not enough material out there. There's not enough awareness and education, and that's something that we're trying to fix. It's a work in progress, just like the whole ecosystem is. And as a maintainer of documentation on the Kubernetes project and as a senior technical evangelist, I really understand that this is one of the key areas that we have to focus about. Because irrespective of how great your project is, how revolutionary and world-changing it is, you need to actually convey it to people. You need to actually make people understand that, hey, this is what you can do with the project. This is the cool stuff that you can do in a way that they understand. So kind of like explaining it to them like they're fine. But there's not a lot of things done in this regard, and it's something we're actively trying to change as part of the ecosystem. And I'm no Gartner analyst. I think you'll already probably know that. But if you know about like this hype cycle curve that Gartner publishes, we haven't even crossed the very first, I don't know, the ascent is not yet even over. That's because we want for this process, we want for this whole thing to be as community driven and as collaborative as possible. And that obviously has a lot of dissent and discussions and a lot of bike shedding and yak shedding. I love those terms, but those are exactly what happen when you are a part of community. It takes a long time to reach that peak, to gain consensus, to seek consensus. And if you'll ever get the chance to watch this, I've included this link, so if you'll ever get the chance, please do watch this video. It's by one of the greats of Kubernetes, and he's a senior developer advocate or staff developer advocate at Google. And in his opening remarks at Cloud Native WebAssembly Day Europe, he spoke about the very things that I spoke about just like 2 minutes ago, about the need for collaboration. Because as much as I actually think WebAssembly is going to change the world in baby steps or in large strides, it actually does need more advocacy. I think having fantastic engineers and intelligent minds work on a particular technology is great, but conveying it to people is actually more important, if not as. I mean, you need to have something to convey, that's obvious, but if you do not, other people won't know about the work that you do. And this is just a very short keynote, I think of 8 or 9 minutes, so I highly recommend that you watch it. And when I talk about collaboration and everything, with respect to the WebAssembly ecosystem, we are trying to come together. And by we, I don't mean just like me and my group of friends, that's not what I mean. But it's an industry-wide initiative, spanning browsers, spanning companies like Intel, Google, everyone else. We're coming together to support and form the component model. Now, there is already work underway in standardizing this initiative and building that experience of improved productivity and improved way of building software. There's already work there, but what we need as a whole ecosystem and as a community is your opinion. And I'm not saying just you or you, but as a collective, we need the industry's help in this. And it is probably unfair of me to give you a sneak peek of what I'm going to talk about on Friday, but this is the component model and the deep dive of it is what I am going to be covering at Web Directions Code on Friday, and I hope you'll join because I promise there will be a lot less rambling. I'm really very excited, and I hope you all will be there. But do come in tomorrow because Kevin's talk is tomorrow. So that's about it from me, and thank you.
Thanks, Divya. We're going to do a bit of Q&A, but first I guess I've got a couple of questions. So, is anyone working with WebAssembly at the moment? Experimenting or actually using it in production, other than Kenneth? And also, right, what about, who actually heard of things like the web GPU, web neural network. People have heard of that? Oh, that's good. That's good. All right. Okay. Very good. All right. So I hope you got a few questions for our speakers. We've come a very long way, and I'm not sure they know what time of day it is or like what planet they're on. But great opportunity to speak to some amazing people. So, have we got any questions?
Don't worry, we don't bite. Just say. At least I.
Oh, over here. All right. Very good. Yes.
Take the opportunity to solve one of my problems at work.
Very good.
So if the company is scared of building PWAs because they're scared of losing data, because the browser can choose to throw out data, right? So if you're offline and then you're building up your browser storage, the browsers are saying that if they reach a certain level, they could just delete it. Is like the file API a way to back up the data more safely, or how do you get past this problem?
Well, I understand your problem is about like eviction. So the web is by the design ephemeral. It means that if you go to a website and you stop visiting for a long time, and there's pressure in the system because it's running out of space, you should be evicting those data. And that is also how it worked with storage, etc. The storage used to be quite small. I think with Safari it was like 50 megabytes. I think then they bumped it up to 1 gigabyte, and I think they removed that restriction yesterday in the next version of Safari. So this is definitely getting better. There's also this API. I'm not an expert in storage APIs, but there was an API where you can ask for like persistent storage, at least in Chrome, and if that is granted, which it should be, then it won't be evicted in that case. So I guess like it could still be a problem. I guess like in reality, it's probably not going to be a big issue. But you just gotta like
promise the business that the customer will not lose their data if the browsers don't promise to keep it.
Well, like you said yourself, like there is something called the private origin file system API, where you actually do like a file on the system. I don't believe that is gonna get evicted. I might be wrong. I don't believe it is. So I think that would be an option for you.
Is that the file API?
Well, originally we developed something called the File System Access API. That is an API where you can access files on your system and directories and work with it. Then Google came up with a new API called Native I/O. That was a way that, basically the issue we had is we had WebAssembly. A lot of people wanted to take existing WebAssembly code and bring it to the browser, especially MySQL. So you could run like a database that requires specific APIs, not regular file system APIs, because there's a lot of privacy and security that makes things slower. So they made a restricted API of file system access that could make this fast. That was called Native I/O. And I remember like reviewing that in the tag, where one of my things were like, why is this a totally different API than the file system API? Like all the functions are different and you're still talking to a file system. Eventually, they understood it. They made an extension to the file system API, file system access API, that would allow these kind of use cases. A specific high-performance local file system that is not exposed in the Internet Explorer and Windows Explorer and all of that. Files that are only available to your origin. So it turned out that Adobe really wanted that for Photoshop, because Photoshop, you have like 5 gigabytes big images, you're zooming around, and that doesn't fit in memory for those people. So they implemented swapping using this API. So now it's even supporting Safari. So Safari doesn't support file system access API, they support the rest. It's kind of the same. They just miss 2 functions. They might get there someday. So anyway, like this is one of those APIs that you should be able to use, and I believe that probably shouldn't be evicted. But generally, like browsers will try to avoid evicting you, especially if you progress a web app you installed. But it could be even with a native app. Like your file system might get corrupt. Like do some kind of sync with a server backing up data. That would be the best approach. If you find out, oh, it's not there any longer, well, you have to sync back. Generally, I don't think it's going to be an issue.
There should be something you're scared of, like
no, if like say you're like airway and do like boarding cars. Like you just interacting with the site. It's not gonna get evicted. It's gonna be the last one to get evicted. So, and like, are you already running around with your phone at like 99.99% out of storage? Probably not. You will already be complaining. So I don't think it's as big of an issue as people believe it is. I hope that answered it.
Very good. All right, so who else needs that problem solved? We're going, this is a pretty inexpensive access to some amazing talent. Other thoughts, questions? Yeah, Chris down the front. Yeah, I'll go to Chris and I'll get to you. All right. Yeah.
Give you a question, potentially, or either of you. What's going to drive WebAssembly forward? Is it applications like Photoshop? Is that, because it's usually that push and pull. Google Maps changed how we interact with browsers and drove APIs with it. So what's the thing that's going to push WebAssembly?
Well, I think people don't understand how important WebAssembly is. Like everyone in computer science wanted to create a bytecode that would run anything. It's so difficult. Java tried, Microsoft tried. Like WebAssembly is the first solution that kind of works. It doesn't support all languages yet. Like there's still some missing pieces for like garbage collection. So right now, today, garbage collection is coming.
Yep.
Not a problem. But like garbage collection in every language is very different. So how do you make a language solution for that? It's coming. They found out a way. Today, like if you don't have garbage collection, you have to port over your garbage collector. So the binary size becomes pretty big. Like this is the bytecode that everyone have wanted. The guy who invented Docker said, had WebAssembly existed, I would not have invented Docker.
Precisely.
It's like show this slide about like, you have this, well, it said like small. I felt like, we have some containers for like some model we tried to install. They're like 8 point something gigabytes. That's not small. I have some slides I'll show tomorrow. I think we had OpenCV port to WebAssembly. I think that was 4 megabytes. Google's Meetup is 2 megabytes. We call that big on the web because we have to load it at runtime, but that's really small. And I think about this for servers. So one of the things, I actually led up the WebAssembly team at Intel when we started. And one of the things I always thought, like, well, this is going to be, like, WebAssembly was for the browser, for bringing existing code to the browser and have it run there. It's like, no, this is going to be amazing on the servers. And people said, no, I don't see it. And now we see it. It's everywhere. Like, this is small, it's fast, it's portable, it's the bytecode everyone wanted. It's going to be for on edge servers. You have like Cloudflare that can tie into that. You have Fastly that is basically WebAssembly running on the edge. You have, I don't know how much I can say. Let's put it this way, like there might even be part of your computer that has maybe the controller for your touchpad. Why is that not in WebAssembly? Why is like allow OEMs or whatever to update this? It's a sandbox. You're not gonna brick the machine by a firmware update. Like the WebAssembly is amazing. It's a sandbox. There's still a lot of challenges. I personally have been fighting people, even internally, like you mentioned WASI. It's a WebAssembly system interface system.
I got it. Sorry.
So that was kind of like a POSIX kind of way. And it's like, man, we work on Project Fugu on the web. Can we please align these two so we can also run WASI on the browser? Yeah, so far it hasn't happened. It was the same with Node. With Node.js, we have the Node APIs and the JavaScript web browser APIs. Now we have Dino trying, hey, I did Node wrong, let's do it the other way, let's align with the web. We have efforts in Node that are bringing fetch to Node, aligning with the web. I'm going to see the same is going to happen to WebAssembly. So you're going to run it everywhere. You're going to get this bytecode with APIs. It's going to take a while. And it's going to be servers, clients. And think about this, like you're doing machine learning, like, oh yeah, I wrote this code. It can run on the cloud. If there's no cloud, it can run on my client. Or I can run on an edge server close to me. It doesn't matter, it's the same code. It's like, so what Cloudflare did, like they took the web, the service work API that people are using and brought it to edge servers. So it's like having people to be able to do front end, back end, I don't know what you call edge, middle edge. Like,
Far back end.
it's like amazing. I think like WebAssembly is going to become amazing. It's going to take a while, but already today it's something that no one could do before. And it's based because we got brought the brilliant experts together. People that worked on native client for Chrome, people that worked on next.js at Mozilla. All these are the experts that brought them together, they made something, and they standardized it. It's like it's standardized, people can build on top of it. It's not this proprietary product. And people starting to realize all those use cases that it can solve. And they keep on adding, like, we work on Symfony, multi-threaded, there's coming, other APIs work on, we even like, people work on WASI, we have WASI parallel, WASI NN for a neural network. Like, it's early days.
And just to add on, I know I spoke a little about the component model, but I truly do think that it's one of the watershed moments for WebAssembly, because not only whatever Kenneth mentioned is obviously, intended to happen, that is one of the visions, but with component model, what we did with monoliths, right? We broke them down to microservices, if you're familiar with that. With the component model, that's what we aim to do, with the way we write code for the front end as well. We're going to break them down into components. And those components essentially could be written in different programming languages. And they will essentially compile to a single WASM component. And that component basically can interface with other components written in other programming languages. And it'll all work seamlessly. But like he said, it's going to take a while. It's not going to be like, hey, we got the component model, now you can start running everything everywhere all at once. That's not going to happen. But we are headed there.
The component model has already taken a while. I think like initially the idea was that the problem we had with WebAssembly in the browser is that you want to talk to some dumb APIs, or like Web Bluetooth. So you have to call your memory, you have to call to JavaScript, that will call those APIs and call back. It's very slow. So on the web, we have WebIDL, we do a standard. So it's all these APIs are C++. Why not call directly? So I think like the component model and other aspects, it changed names a few times, so I don't know what the current focus, but like that was the idea, like how, let's just call directly. And when they get the component model right and you can mix and match, it's going to be amazing. So, yeah. Early days.
Oh, hang on. Do you want to say something or ask something?
Say something.
Oh, good. All right. Yeah, right. Okay.
So, just to add to all that, I think one of the main things is there's these big companies with huge legacy code bases, which they couldn't possibly port to JavaScript. And so, a couple of great examples: Unreal Engine, Unity. They're not going to be rewriting those in JavaScript. They've got their huge C or C++ backends. What they'll do is they'll get Web GPU, then they'll get WebAssembly, they'll get a team of engineers, they'll port their existing code to WebAssembly, pipe it out to Canvas, and suddenly they've got their massive legacy code bases working on the web. And unlike all the existing products where they have to have very specific target deployment targets, they can just have, use a physical website. Online, for example, you can go, a great example that I've played before is you can get the original Diablo and you just visit the website, and just load and start playing straight away. And it's one-to-one identical. Now, that's a very old rendering engine, but there's people working on Unreal Engine 4. If we got web apps to the standard where they were viable, then you would get these big companies suddenly going, hey, the web, let's build a deployment target for that. Let's invest in that. But it requires all of these technologies to be stable and to exist for them to be able to do it.
Yes, and it aligns with certain business models compared to other business models. So I think it's really, particularly in gaming, if we've seen what's happened with the likes of Fortnite over the last couple of years. So there was actually an Emscripten version of, was it Unreal? Like we're talking like 10 years ago. One of the engines, or at least a subset of it, and there was like an Angry Birds. You could play the original code base of Angry Birds in the browser. But this is like 2010. I think we ran a conference.
And Quake.
And Quake.
Quake, yeah.
Oh, yeah. Right. What about Duke Nukem for it? Does that still, did that ever, don't mention Google. Now, sorry, but now, back to you. Yes, I did remember.
My question literally was like, springs perfectly to that, because it's like, with the power of web GPU, are Unity, the likes of Unity and Unreal getting on board? So obviously it seems like the answer is already yes. Like, it seems like it is going to be a game changer in terms of getting their sort of legacy code bases, in terms of gaming, in terms of into WebAssembly.
Well, I think it was one of the original drivers. So obviously Intel, you're close with a lot of their kind of gaming. Are there any, like in terms of porting game engines to WebAssembly into the browser, is there anything you can talk about or anything you're familiar with in that area?
Yeah, I think like especially from the Mozilla point of view with ASM.js, that was exactly the point. They're working on Unreal Engine. And I think like it's working today. The big issue the gaming engines had is that WebGL was crap. And now we have WebGPU. So I don't think that's going to be an issue. One of the other focus on, like if you look at ASM.js and WebAssembly, one of the reason why we did WebAssembly was because ASM.js, compiling everything to JavaScript, it worked. But like the files were huge.
Yeah.
And the web is about like click and 2 seconds later you're in the experience. So WebAssembly was designed.
You haven't been in Australia very long. That doesn't happen.
Sorry?
You haven't been in Australia very long.
Okay.
Takes a little longer.
Okay, so 10 seconds. Some kangaroos jumping around. Like that was really the point. Like how can we create this byte format that is really small, that you can load really fast? That's always been one of the focus of WebAssembly. So definitely there's a lot of focus on getting game engines running, especially initially. And then I guess like the focus became on bringing over existing code bases, like getting like Autodesk running, Photoshop running, all these existing Figmas also implement running with C++. It still enabled other people to like find like code that was too slow to write in JavaScript. So most of it is written in JavaScript. Even like Photoshop, the UI is JavaScript. It's with HTML, I believe.
Yep.
Yeah.
And they'll just like then write the rest in WebAssembly.
Excellent. All right, we got way up the back. Project.
You want to maybe speak to the concept of, for example, Apple not really wanting people to use apps in the browser because then they won't be using the platform.
We might have the right person for you can refer to. Intel doesn't have to talk about it now, right? So just
my personal opinion. But
quickly introduce yourself and what, because this man has been doing a tremendous amount of work around this.
Hi, my name's Alex.
That's a microphone. So.
Yeah. Hi everyone, I'm Alex. I run an organisation called Open Web Advocacy. Basically, our organisations goes around the world talking to governments and regulators and basically getting them to try and force the big corporations, predominantly Apple, to stop doing anti-competitive behaviour to block browser competition of web apps. Now, I don't know about you guys, but if the majority of people are here are front-end developers, I'm guessing if you've built a mobile website, you've had issues with Safari before. Can I get a show of hands if anyone's had Safari bugs? All right, I'm a front-end developer myself. We did web apps since 2009, 2010. And the problem is Safari was just full of bugs. There's bugs all the time. IndexedDB constantly crashed, the app would freeze. And yeah, we had to rewrite all of all the scrolling in JavaScript just to get around Safari bugs. And it got to about 2018, and I started asking myself, well, this is ridiculous. We don't have, it's unstable. We don't have push notifications, and we can't install any other browser because every browser on iOS is essentially Safari. So in 2021, we finally got sick of it and we formed Open Web Advocacy, and we decided, well, the reason Apple's not investing in Safari is they have no competition. They get around $15 billion from Google per year just for search engine placement. So that is money that Safari earns them through, just by having the default search engine. The other thing they get is they get about 21 billion from native apps. if web apps are capable, and you've got to think about all the apps on your phone, how many of those apps, if the operating system allowed, could you rebuild as a web app? And on my phone, I'd say it's about 90%. 90% you can build identically as a web app. Except, suddenly you don't have to pay Apple or Google anything. Like you don't have to pay them a 30% commission on every purchase, every in-app purchase, and every sale of every digital good. And so Apple's got huge incentives, one, to push you away from web apps, and two, just not to fund their own browser. Now, the thing that will make Apple fund their own browser is the threat of losing users to other browsers. So Apple's very happy at the moment. We can say, I think they've got a 90+% share of browsers on iOS, but it's really 100% when you consider it's all Safari. But if they're suddenly worried that users are going to start fleeing to other browsers, then what are they going to do? Start investing in Safari, trying to capture those users. And so what we've been trying to do over the last 2 years is just go to regulators and legislators and just explain how important this issue is. It's not just about the web, it's not about web apps, it's about the future of apps. And the thing is, if you think about the web as a free and open source alternative to to native apps, then suddenly the native app stores have to start being really nice, because you've got all your native app developers, and if Apple and Google are too mean to their native app developers, then they might start going, well, maybe we should be building web apps instead. Yeah, does that answer the question? Yeah, so really the motivations are $15 billion from Google, $21 billion from apps, and that is a massive percentage of Apple's profit per year.
But I think you can say that it's working.
What's working? Oh, well, yeah. So as far as our successes go, we've now got the US, the UK, Australia, the EU, and Japan to all make recommendations that the Apple browser ban gets overturned. And in the EU, we got it into the Digital Markets Act. We got browsers and web apps in there. So 2024, in the EU, they're mandated by law they have to allow third-party browsers. And Google and...
It's basically this guy. Okay, so like seriously, like when the world changed, Alex, a staggering part of this. Like the amount of work this guy's done, it's just I'm just so impressed with what you've done in all, because like there are a lot of people around to help, but Alex has just been amazing. Like anyway, so yes, the applause was very, very welcome, and no one really knows about this, but it's kind of right.
The problem is, you know what Apple's going to do, right? If the EU's mandating the law, it's just going to be Europe. They're going to carve that out. And so we actually need to fight this in every jurisdiction. And so we need to get several major ones. Once we've got it in Europe and Japan, the UK and Australia, then maybe we can start applying pressure on the US and get them to change their laws to force it in the US. But we really need all of your help. And the way we need your help is when governments say, hey, what do you think about this issue? We just need lots of companies to write up an email and say, hey, this issue is really important. It's cost my company this much money. I got forced to build a native app because my web app didn't have this feature or that feature. Yeah, that's pretty much it.
Well done. Thank you, Alex. Thanks, mate. Have you got... Yeah, like, give him a wrap. And he's going to give a bit of a wrap up on Friday after a bit more detail about what the efforts are and so on. But certainly, like, the ACCC, European regulator, UK regulator, Alex has been talking to them, and they are paying attention, right? Like, yeah. I've been on a couple of these calls, and the Japanese wanted to go way further. What did they want to do? What did they want to do?
They wanted to make it in-app browsers. They wanted,
everybody can make their own.
They wanted every app to be able to have its own browser engine. Now, which sounds good in theory, but the problem with if you want to make a capable browser, it needs access to basically everything on your phone. And that's okay if you've only got like 10 or 15 browsers. You can have a very special process that goes, right, you want to make a browser, you need to do all of this criteria. And we need to know who you are. If you do anything wrong, we're going to boot you. You'll get your permissions revoked. But then if you give that permission to every app, do you really want every app on your phone doing just-in-time compilation? Probably not. And that's why I started outlining. It's like, yeah, let's hold up here. We want browser competition, but we don't want to open the floodgates because privacy and security is still incredibly important. Happy to answer questions if anyone's got any. Yeah.
Do you have any thoughts on the other side of the fence? Because obviously you're sort of calling out businesses reaching out to government and saying this is a problem for us. But you are seeing a large number of businesses who actually sort of push forward the native apps. They know they can kind of get better loyalty channels by getting their users over to over native apps, and they're actually pushing the idea of getting users onto their native apps. It's better for them as a business. Do you have any thoughts on?
Yeah. Okay. So the question is, why do you think the app stores are successful in the first place? Do you have a good idea about why you think they're successful? Because
it feeds into exactly that.
It's pretty much the reason native app stores are successful is they've either blocked or hindered every other alternative installation method. The reason everyone goes to the Apple App Store is there is no other way to install apps. You are forced to go to the App Store. So there isn't another option. If you talk about how people install apps, about 50% of all installs on an app store is somebody going to the App Store, typing in the name of your app, and clicking install. The other 25% is somebody seeing an advert or seeing a link and clicking on it, then getting redirected to the App Store, then clicking install. And the last 25% is adverts from other apps that transfer into your thing. Now, if we had a situation on mobile devices where I could send you a link or you could see an advert and you visit the website and it's just got an install button on the top of the website and you can go, yeah, I want to use that app, install, then suddenly the advantage of the App Store goes away. Now, not only that, is the web is significantly more secure and private than native apps. So when they were developing native app ecosystems, they kind of like, quick, let's build a native app ecosystem, let's give them all the permissions in the world, and we'll trust App Store review, which happens to consist of 500 people who have to review 100,000 plus apps per week.
Compiled apps.
Compile, like they're already compiled, you can't view any of the code. They're not software engineers, and they click around the user interface mainly to enforce Apple's billing rules. And so, whereas you've got the web, you don't get any of these permissions. So they don't get access to, carte blanche, Bluetooth, or device APIs, or addressbook or anything. Right? They're really locked down. And so you don't need that App Store review. And so if you're trying to sell an app, if your users had the ability to easily install it just by sending a link or doing an advert, then very quickly you would be able to get just as many users as the App Store. So I think the theory that the App Store is the thing that's driving the sales is just not true. It's just because they've blocked the alternative installation methods. Yeah.
All right. Have you got anything to add there, or
Well, I just want to say that
it's okay now because you've got nothing to do with that one.
Yeah, I just want to say that it's really working because Apple didn't hire anyone for a long time, and nothing was happening. And suddenly there was pressure to know what's going to happen, and they started hiring a lot of people. They started implementing a lot of people. Like I worked on the web screen lock API, so API that allows your screen not to turn off because it's a recipe site. You have dirty fingers, you don't want to touch your phone or your laptop all the time. People are already doing that by playing a video off screen, draining battery life. So insofar, it's a good idea we make a native API for that. So we actually get better battery life on our laptops. So I did that. We got the head of, I don't know what Mathieu's job position is.
Head of WebKit.
His head of WebKit. And he was joking like, oh man, this is gonna be so safe, ha ha ha. Something like like this, like we're never gonna implement. What happened? They implemented it. Like all these API, like Apple, like when we did the product Fugu, they're like, we hate Fugu. Whatever API we did, Apple is against by default without having looked at it. They will say because of privacy. We don't like it, don't like it. Now I think yesterday with the latest version, I think Thomas Steiner from Google tested it. 26% of Fugu APIs are implemented by WebKit now and work in Safari. Those APIs they would never want to do because they're dangerous. Oh, push notification, no, we don't want it. Service worker, no, we don't want it. Oh yeah, websites load slower and Safari. Oh, we have service worker, that's great, it's perfect. Push notification, no, oh yeah, oh by the way, now it's there. It was the worst thing ever, but it's there now, it's cool. We also have the batch API, also not cool before, but now it's awesome. It's like with our friend like Alex Russell, he always said this thing about Apple is that he was like defining the strategy for Google, and the strategy they ended up with like, we're just gonna do it and move ahead, and eventually they're gonna do it. They might not do 100%, but then maybe they'll do 80%. It's gonna happen. Like we have like they didn't like the file system API. Okay, they still don't like it, but we have privacy-oriented file system API because Adobe wanted it for Photoshop. If a lot of developers start using Visual Studio Code and it doesn't work in Safari and iPad, and businesses say, no, I don't want iPad because I can't run my businesses. Well, they're gonna do it. It's just a question of time. So let's just like keep on adding those things, and eventually they'll get there. Pressure works.
Yeah, our estimates is they hired about at least an extra 60 to 70 people on their team since we started. And the thing is, before, the team wouldn't have actually been able to develop any of these AIs because there was such a small team. They could barely keep up with the bug fixes and the patches. But the thing is, it's really hard to go to management and say, hi, can I have an extra $100 million per year because I want to build some web features because there's no business case. As soon as you go, our product earns $15 billion per year and we're going to start losing market share to the other browsers, then that suddenly does become compelling. And that's why we really need to ramp up the pressure to ensure that there's browser competition on all devices everywhere. And Apple's not the only, Apple's the major bad player, but obviously there's problems with Google as well and Microsoft. They're just lower order problems, so we don't focus on them publicly as much. But we still, when we talk to regulators, we still go after them just as hard. So.
Yeah, like the Apple team was really small. I think like the WebKit team that used to work at WebKit, it was like around 50 people. And I actually was supposed to join Apple. I didn't go because I had to move to the US within a month. So, but at that point, I was supposed to work on iOS Safari. I believe there was 7 or 10 people on the team. That was it. And Google had like 500. They probably have 1,000 or something now.
There used to be a joke in the industry that Google's security team was bigger than the entire WebKit team. So it's,
It wasn't a joke.
Oh, yeah.
No, seriously, I've heard about that, yeah.
But just to clarify, we want Safari to succeed. We want Apple to build the absolute best browser. If Apple came out and said, right, we're going to spend as much money as possible and we're going to win the browser battle, that's exactly the outcome we want. So we're not really against WebKit or Safari. We're really fighting Apple management. To
put it in historical history, like look at Microsoft, like the one with Internet Explorer 6, like, okay, now we have the market. Then they fired the whole team. There was no one there because like we won, so we don't need to develop the web, right? It doesn't matter.
What these big companies do as well is that when they're happy with a product or they don't feel like they might not even fire people, they just move them to different departments and say, all right, yeah, you're going to go work on this. Because all the people working on the Safari team, well, they can work on Apple Mail, they can work on any of the web technologies, and so they can just move them from one project to another. And they'll do it again if there isn't the pressure. Because as soon as they get bored, they'll switch back to their old ways.
Actually, the interesting part is that a lot of people work on WebKit at Apple. They don't work because of Safari. they work for, I know people there, they work on iBook. So iBook is basically WebKit. Or they work on the App Store because the whole App Store interface is also WebKit. There's a lot of native apps on iOS that are actually built on WebKit.
actually,
You just don't know.
settings, a lot of the actual system widgets, you can now
I don't know how it is today.
developer tools and
Originally, when I interviewed for Apple, the whole OS was based on WebKit. It meant like input and text rendering was done by WebKit. So that's why they couldn't update WebKit separately from the OS, because everything depended on it. I guess that today they probably have like multiple versions of WebKit running on iOS, because I don't think that has changed. They just build like native elements around WebKit, because it's brilliant. It can render all kinds of fonts and Japanese and Korean and Arabic, and it all works perfectly because it's the web.
So like Brendan and I said all those years ago, always bet on the web, right?
Yeah.
Bet on the web. So
he said
you're in the
like
right place.
He said like bet on JavaScript though, but
Yeah, we did.
we said bet on the web.
The other aspect with the native ecosystems that you've got to appreciate as well is that if you're investing in native app ecosystems, that gives that company lock-in just from your investment and experience of that ecosystem. If you've spent the last 10 years investing, building Swift applications, you're not suddenly going to go out and start building Android applications. Like it's a completely different ecosystem. And then if another mobile provider comes along, well, what are their choices? I mean, iOS is a closed system, so they can't use those. Pretty much, they're going to have to license Android, right? Because otherwise, if they don't have that library of apps. If we manage to be successful with web apps and we get the majority of high-profile apps as web apps, then suddenly that will completely open up mobile competition, because another mobile company could come out and go, right, we've got a device, we've got all these apps, we've got a viable device. Apple 100% doesn't want that to happen. If you can suddenly, if they want all of, as much as possible, they want their apps to be exclusive to iOS, or at least exclusive to iOS and Android. They don't want competition number 3, competition number 4. And that's why we only have 2 ecosystems, right?
It's just business. It's called tie-in. That's why you have iMessage. Like, don't want to open it up because like your parents are using it, so you want an iPhone to talk to your parents and your family. It's like that with everything. It wasn't better with Microsoft. You saw like a lot of like old apps were done in Windows only. And like they're like, I'm not coming to the Mac because I have to rewrite my whole Autodesk or Photoshop. It's gonna be impossible. That's why a lot of those legacy apps are looking to the web. First of all, like, I'm not gonna do an iOS app and an Android app and a web app. Like I don't have the money for that. I don't have the skills or the people with the skills. So, but the web is like, it's future-proof. The other thing, like with native, you might do like a Flutter app today. That app might not work in 5 years because it's deprecated APIs. You need to update it. That's always what happens with native APIs, because it's just how it is. Like they're replaced and you have to migrate. The web has this history that it needs to stay working. Like you can take a website I wrote in the 90s and it still loads today. We do remove a few APIs that are really bad, but we have to really carefully look at like how many people are using it, what's the percentage, can we remove it without breaking the whole site? Otherwise, like, too bad. If you ever had new APIs we wanted to launch, like, oh yeah, there's this framework called Mood Tools that have this function. It can't be called contain, it should be includes. We changed so many APIs because there's something out there that will break. Like the web should stay working. It's like it's 25 years old.
No, it's older.
It's like,
Yeah,
yeah.
depends on what you want to call it, but at least.
It's the W3C that's 25 years old.
It was
Yeah.
So it's probably like 30 years
Still
old.
at 1990 for.
And most of those websites they still work. And they're gonna work in 10 years and 20 years. How many old, you can find some DOS apps that will still work, but like how many like iOS apps from 10 years ago will work today? No, because like no, they have to be 64-bit now today. So they don't work. So
I think that's a really good place to wrap up. No, I think, and leave with that thought. I mean, we're all web people, and sometimes it's been, there've been some rough moments over the last kind of decade or so. It's been, like web versus native, but I think the promise of the technologies, we'll touch on it a bit at the conference, but things like web components, edge computing, and then things like view transitions, where, there's a bunch of reasons why the way we've been building kind of web apps over the last 10 years probably is less important than it has been. In a room full of React developers saying that SPAs maybe aren't the future, maybe is not what I should be talking about. But I think we're on the cusp of these technologies coalescing perhaps into a new way, a more lightweight way that we build web apps in the coming years. If you want to continue that conversation, the Golden Fleece, I believe, is it close by, Anita? Yes. So you're going to follow someone who looks like they know where they're going. Or look it up on one of your devices there as well. But before we do, could we please thank our wonderful speakers for tonight? And Alex jumping in there, but thanks, Alex, that was great. Thanks to Anita and Kogan for their wonderful hosting. Remember, they're hiring. So if you're an engineer and you're kind of looking for your next role, please look at it online or just go and have a little quiet chat to Anita. So thanks to Kogan. Thanks very much for that. Appreciate it. And the food and the beer, we really appreciate that. And then to the meetups, we're at React Melbourne, we got CSS Melbourne, we got next.js, and Refugees Code Melbourne, who a new meetup, who are kind of working to get refugees who often really have a lot of challenges in Australia because they can't necessarily work, and getting together, learning to code. If it sounds interesting to you, just get a hold of me and I'll put you in touch with the folks who are doing that. But thanks to you all for coming. We'll see you at the Golden Fleece, see some of you at the conference, and then React Melbourne and Melbourne.js and Melbourne CSS have got events coming up in the coming weeks and months, so get along to all of those. And thanks once again for coming along. Of course. Let me know. I'll happily. No. Yeah, but I'm happy to. All right. You got all your things. Apple are watching.
Hello.